exams of IGCSE Chemistry in June 2026. Usually, if students to take this exam, they're gonna have to start like 9 months before the date of the exam. So that's what I'm gonna do today. I'm gonna draw a timeline for students on how they could study, what's the best study techniques, the chemistry syllabus, so the structure of the chemistry syllabus, and how they could manage to achieve better results, because I think it's not a difficult subject. Most students can understand chemistry. It's just like how you could study and achieve better results. So that's what I'm gonna do. Now, for those on Zoom, if there is any question at any time, you're more than welcome to raise your hand. I have your names here in front of me. So just raise your hand if you have any question. Or second option, you could just write me, and if you don't want to speak, just write me your question here in the chat box, okay? So let's get started. So my plan is gonna look something like this. I have the target first. So that's how I always think of my projects, my targets. I think of what is my target. Now, for any chemistry student, the target should be to aim the highest, an A star, a 9, depending on the grading system. Now, targets alone could just be dreams if you don't work for them. So we're gonna divide step by step, on how you could achieve to this target. So we're gonna draw a timeline of 4 steps from September all the way to June, so you could achieve your target. We're gonna make this timeline realistic, meaning we're gonna set certain date, month, so that we could get to the finals. I'm talking here about May 2026, June 2026. All right? And more important is to keep track. So when I'm planning for something, I just keep updated of where am I, how much have I achieved, okay? So that's how we're gonna track our progress. So that's my plan for today. So let me show you the things we're gonna be doing, just 5 things. Number 1, we're gonna set the important dates. Second, we're gonna see how exams are structured. Very, very helpful to understand, like, how's the exams gonna be like at the beginning of the year, so you could plan according, okay? How we could communicate, like teacher, parents, students. I'm gonna show you a very efficient way, especially for parents, this one. How could you keep track of your child's progress? Best study tips. I'm talking here about study tips that change completely how you approach the subject. And the exam papers. We have 3 exam papers. I'm going to show you exactly how much is the weight of each one of those exam papers, and how you prepare for them, and what order you study for those exams, okay? All right, let's get started. First, the important dates. We have 1st September. We're gonna be starting here, 7th of September, the first Sunday of September. We're gonna be having 2 classes, 1 class on the 7th and 1 class on the 10th. So every week we have 2 classes. Now, usually that first class is theory. That's the one we I explain the content, right? So you must understand the topic, then you practice on. So Sunday's class is practice. Sunday's class is where we study. I explain the content. I do solve the important questions that help you to further understand. And Wednesday's class is where I solve questions. So you can see that's like every week 50% is theory explanation, 50% is me trying to solve, because they're just as important. You may understand the whole subject, but you don't know how to solve, right? So that's how it's gonna be. Plus, every week we're gonna be having a progress quiz, you can call it. So quiz to see how much you understand. So that's our weekly plan from September all the way till December. Okay? So by December, here, Wednesday, it's 24th, we'll be done of 60% of chemistry. So we'll be done of 60% of the content. We're gonna be having 1 week holiday, and when we return back in Jan 26 next year, here we're gonna be having a mock test. 60% of chemistry, you'll be asked questions about those 60% you've done. So we make sure that you have completely understood and you know how to solve that much of chemistry. Now, Jan till the end of Feb, okay, so from here to here, we'll be done of chemistry. So by the beginning of March, every year I do this, been doing this for 20 years, we'll be done of everything in chemistry. Starting from March 3rd, here we're gonna start revising, meaning I'll be solving full exam papers, okay? I'll be drawing along with the students, I'll be drawing mind maps. Those are very, very, very useful. We try to link all the different areas of chemistry, because many times in the exam you'll find that the question is asking you from first topic, third topic, and the fourth all in one question. So that's gonna be very helpful, where I do mind map. That's one I did last year. I did a mind map connecting all the topics of organic chemistry. Now, as I said, we must be communicating. So that's how I follow along with the parents. So every week we'll be updating the parent about the quiz, the grade of the quiz. There will be a test every month. So we'll be having 9 tests, September, October, November, and so on. The homework, because there'll be a homework every week. So if the student submitted the homework, student did not submit, if he copied the answer, so that is going to be sent to the parent every Friday, progress report on whether the student is achieving or if he or she is not. Okay. Now, for those who are watching on YouTube, I can't answer your questions because I'm here on Zoom, so I can only follow on one platform. I can't answer questions. But if you can leave the question, you send me email, you send me WhatsApp, I'll answer you. All right. Let me now show you what the exam papers are going to be like. So we have, as I said, we have 3 exam papers. We have paper 4. That's the largest exam paper we have. That's 50% of chemistry. It's an easy 50%. That's like you study, you get the result. Okay? You have another paper called paper 6. That counts 20%, okay, of chemistry, 100%. And that is paper 2. Okay, so 3 papers. Each one asks you about something different. So paper 4, it's theory questions. So they ask you like, what are the 3 states of matter? What are the particles you have inside an atom, and so on. Okay. Paper 2 is gonna be like paper 4 theory, but it's gonna be like multiple choice questions. For most students, that's the most challenging one. And we're really lucky that the exam date of paper 2 is always the last. So you have plenty and plenty of time to practice for paper 2. Paper 6, it's 20%, right? But this is not gonna be an easy 20%. That's what sets a good student from the best student. This paper here, 6, the practical one, is the one that requires skills. You need to learn those skills gradually, right? So again, with paper 6, sometimes students, teachers keep it to the end, but you shouldn't, because with this paper 6, you need to practice gradually so you develop those skills till the end of the year. Okay, now I want to show you what the exam papers are like. So that is paper 2. Okay, it is multiple choice, 40 questions. Each question is worth 1 mark, so 40 marks. And each mark is 1.5. I need to explain this, just bear with me. Each mark on paper 2 is worth 1.5 of your total. Okay, so I was talking percent. Now I want to tell you what is your maximum mark you can score. So the max you score is 200 marks. Okay, so you take those 40 questions here, 40 marks, and you multiply it by 1.5. Each paper, there is marks, and there is the total from that 200. Okay, that's paper 2. Let's get to paper 4. I told you paper 4 is 50%. So see how is it gonna be calculated here? You have written questions again, all are written, no multiple choice. You have 7, sometimes 8, 80 marks. Each mark here is 1.5. So you take your score in paper 4 and you multiply it by 1.25. Okay? So again, we're gonna take all these marks and they're gonna have to add up to 200. And what about paper 6? That's 20%, we said. There are 40 marks. Each mark on this paper is 1 mark. So this will now make sense. Let me show you. So paper 2, we said 40 questions times 1.5 gives you that 60 from the 200. Okay? Paper 4, again, you take the marks that will add up to 100. And paper 6 is 40 from the total mark you should be scoring. Nobody scores that 200, to be honest. Let me show you how much you should score from that 200 to get an A star. So this is from last year. If you are to score an A star from the 200, you need to get 167, which is quite achievable. Okay, so minimum you need to lose like 33 marks from the 200 so you could score an A star. It's quite easy, it's never difficult. Majority of students do score an A or A star, those that prepare like for that from the beginning of the year. Okay, so again, does that make sense? Does the number of marks, the 50%, the 40% make sense? All right. Now, what I also want to show you, I want to show you like the best way you can study for this subject. So I'm gonna start from the time, let's say you took that lesson on Sunday. So I'm gonna start with you from Sunday on what you should be doing from the lesson all the way till the time you do the exam. Someone's asking me which paper is the first exam. Usually paper 4 is at the end of April, like 30th of April, 29th of April. That's how it's always been. Then comes a couple of weeks after paper 6, and paper 2 is in June. So paper 4 at the end of April, last couple of days of April, paper 6 first 2 weeks of May, and paper 2 first 10 days of June. The dates are not fixed every year, so like around that time. All right, yeah, so let me show you. Let's say that you took a lesson. Now, what I usually encourage, sometimes I try to force this, I try my best to keep the students engaged during the lesson. So, while attending a chemistry lesson, you should be always on track. I always do it by keep asking the students. So for instance, let me try this with you. I pop a question like this, okay? And I press here, okay? And I ask the student a question just to make sure that they were actually watching, because many times people lose focus. So if you are always been asked every now and then, you would be on track, okay? So my question is, I just said that, right? How much percent is paper 4 of your overall, right? See, good. Everyone got it right. Almost. Somebody thought it was 40. No, paper 4 is 50%, okay? So yeah, so that's how I always do it. And I do it without warning so that students stay on track. Students just know that at some point they'll be asked. And I do ask questions personally to students, okay? So, and what I really recommend is, while the lesson is going, just open your notes. Don't write after me, that's waste of time. No, open your notes and just read along with me. Usually I follow the exact same order as it is in the notes, okay? If you would like, while the lesson is going, just annotate, highlight, so you just keep on track, okay? That's the first part. So you took that, let's say you took that lesson on Sunday, that's what you've done. Now, what I strongly recommend is, Sunday you took the lesson, right? Sunday night, Monday, maximum Tuesday, you should go over that lesson. You must revise it. You will completely forget it. We're continuously on our phones. We're bombarded with very unnecessary information, so we forget. So if you don't revise the lesson, it will be completely wiped out from your memory, okay? So Sunday was the lesson. You must book in your schedule time on Monday, on Tuesday, time for you to study what you took. It would take you max 30 minutes to revise it, okay? And another hour to solve questions. If you do this, promise you will remember this for a long time. So let me show you this. This is somebody who took the lesson, okay? First day, he or she could understand that much, okay, of the lesson. Let's say that's like 70%. If he doesn't revise it, it would drop all what he learned, she learned gonna be forgotten. But if he just invested in half an hour, 30 minutes, just going over the things that he took, she would, remember, retain the information. And notice we did not reach 100% of what we've learned, because I'm going to show you now what do you do to increase your knowledge, practice, and skills up to 100. So again, that's the revision. How are you going to revise? You're going to do quick scan of the notes. So you remember those notes you were going over during the lesson? Just read them. Okay? Then, what's very, very important, you must solve. So you'll be given a homework. Okay? Solving those questions of the homework would retain the information in your mind for a long time. So what I recommend, just give me a moment. I just need to open the door. One moment. All right, yeah, so if you just do that reading, so we said like 30 minutes you read what you took, and twice as much, 60 minutes, you solve questions. Always try to solve more and read less. Reading is very, very passive way of learning. But if you solve, even if you solve with open notes, it would be just as good, okay? So always in any subjects, not only in chemistry, you spend, let's say, 30 minutes reading, 3 times more, 1 hour, 1.5 hours solving. That would help you to recall the information from your mind and remember it for a long time. All right, so now we're going to Wednesday, because we said on Wednesday I'll be solving the homework that you were given. So you've been given the homework, I'll be solving it in front of you. So you see what the best way to solve. And meanwhile, let's say you couldn't solve a question, or you had a question very difficult for you. There is a WhatsApp group. I'm gonna send you the link to it at the end. This WhatsApp group, you can ask your question. I'll answer your questions myself. Now, after that solving session, we'll be having a quiz. Okay, so that is gonna be mini quiz every Wednesday, just about the topic that you took this week. And after doing this, after taking the lesson on Sunday, revising it, solving, watching me solving, doing a quiz, I promise you that you will be retaining that information, understanding what you took fully. Okay, if you do this recipe, 4 steps, it's gonna work. Worked for so many years, it's gonna work for you. Now, test. We said every last Wednesday of the month, so last Wednesday of September, last Wednesday of October, there will be a test. That test is not gonna be about one topic, it's gonna be about all the topics that you took this month, okay? So that is gonna be one test. Now, let's say you didn't do well on that test. So there will be dedicated time on Friday where myself, and you, we can go over the test and see what are the areas that you don't understand. And as I said, we'll be having 4 mock tests. One we said is in January. A mock test is like a test quite very similar to the finals, and it's meant to take all the topics you took and having them in one test. So we're gonna have 1 in Jan, we're gonna have 3 in April and May, okay? So that is probably the best way you can study for chemistry. And again, if you have questions, tell me. Okay? Now, let me go over subject of chemistry. So I'm gonna show you what is this top subject is all about. I'll do like the entire chemistry in maybe 3-4 minutes. Just something to keep in mind. I may mention things that you've never heard of, you've never seen. It's just like the name of the topic that you'll be studying that in the future. Okay? So let me start. Look, in brief, what is chemistry? What do we do in chemistry? Chemistry is study of substance, study of matter. Matter is like everything around us, okay? So chemistry is the study of substances. So that's why the very first thing we do in chemistry is matter, okay? We do the states of matter, meaning what is matter made up of, solids, liquid, gases. We do purification, meaning how you could take something that is impure, like my coffee, and purify it. And moreover, we study the building blocks of matter. What is the basic units, the Legos, think of it that way, the Legos that you build larger things from, okay? So that is the first topic. Each one of those blocks you see here, each one of those takes you one lesson. The second unit is bonding. Remember the matter and particles that make the matter? This part is where you learn how these particles are attached, how they join together, okay? So we'll be learning about 3 different ways that particles can join one another. We have some bonds, attachment, call it ionic, covalent, and metallic. So these are the bonds or the ways particles attach to one another, okay? The third part is the part that involves calculation. So that's like the math part of chemistry. It's not like deep math. If you're really not good at math, that doesn't mean that you can't do well in this part. So this calculation part is like the one where you could find like someone, that's an interesting part actually. So someone gives you this ring and asks you like, how many atoms are there in this ring? If you learn this topic about chemical equations and something called the mole concept, take you like 30 seconds and you would find the answer. Now, you see this star here? Every time you see this star on a topic, this means it's gonna take you more than one lesson. So this is one lesson topic. This is gonna take you 3 lessons to finish, okay? Then we have like physical chemistry. So that was like the math part of chemistry. That's like physics and chemistry together because we study electricity. And what would happen if you apply electricity to some substance, okay? So we study something called electrochemistry or electrolysis. Then comes something called kinetics. Kinetics is how you could determine the speed of reactions, how fast and slow reactions are. We're getting near the end. So now comes what we call inorganic chemistry. So that's like the chemistry of everything that is non-living, okay? So we usually have in chemistry falls into 2 parts. Organic is study of living things, study of chemistry of living things. Organic, and that's study of non-organic or inorganic. And this one we do acids and bases. We do how you could identify particles or ions, meaning if I give you a sample, I'll tell you what is there in this sample. We study metals and we study the periodic table. This part was introduced back in 2023. Note that this year there is a new syllabus called 2026, but they did not change much, okay? So this is like a chemistry of the environment. So we study about air, pollution, and so on. Finally, organic chemistry, chemistry of the living. So we study how we extract chemicals from crude oil. We study about acids like organic acids, alcohols, something quite tasty, smells very good, we call them esters. Those are the ones they put in food flavorings. And we study about polymers, plastics, and their environmental problems, right? So this is all what you're gonna study, nothing else, okay? It's good to have a screenshot of this so you know. Okay? Now what I'm gonna do next, that's the last part, that's 10 minutes. I am gonna just show you a mini model lesson of chemistry, so you apply what you've just learned on this lesson. That's the first lesson of chemistry. It's called states of matter. Now just think about it. How many forms can water be? Water could be in this form of ice. It could be in the form steam, water vapor, gas, and it could be in the liquid form of water, the most common one. So again, there are three states of matter. You have solids. In solids, you see how the particles are in a solid? They're very, very tightly packed, organized. They are touching, and they are, the only motion allowed here is that they could just vibrate. So that's like a crystal of a solid. If you ever had the chance, nobody can see this, but that's how we imagine, that's how we believe the particles are in a solid. They're very well organized, touching, and the only motion allowed here is vibration. Okay, solids. Liquids. How the particles are in liquids. So again, you have a liquid and you're looking inside the liquid. You'll see those particles, but how are these particles going to be like in a liquid? This time, see, they are still touching, right? But think about it. What's the difference between those particles on the left, the solid, and those of a liquid? You can tell, right? On the left hand side with solids, that's a solid here, with solids the particles are organized, regular arrangement. Do you see how they are in the liquid? This time they're random, okay? Still touching, but random, and they have more freedom to move, okay? You can see they're sliding this time rather than just vibrating, okay? So that is the case of a liquid. We said the three states, right? Now let's come to gases. So you take a gas, this time the particles, total freedom to move. See how they are? Okay? So we have freedom to move. The particles in a gas are actually distant, and that's something common between liquids and gases, is that they are not organized, they are random. Okay, so again, quick recap. There are three states of matter. Okay, the particles, if you look at those particles in a solid, they're going to be different than liquids, different than gases. And the main difference is that in solids, they are organized. In liquids, they're random. They slide rather than they're free to move. And in gases, it's like random and they are totally free to move. Okay? So this is about the three states of matter. Let me just explain. Like, doesn't make sense. Why is it that in solids they don't move? Particles don't move. And why is it that in liquids and gases they can actually move? And that's something you have to keep. They do ask you this question very often. Why is it that particles in solids are not able to move? This has to do with the way particles interact with one another. You see, I took some particles here, and you have to think of it that way, that particles attract. Okay? There are forces of attraction between particles. If these forces are strong, the particles cannot move, then it's a solid. Okay? So these are very strongly attracted to one another, then we're in a solid. If these forces of attraction are loose, quite loose, then it's a liquid. And if they're very weak force of attraction, then we're talking here about gases. So again, every time someone asks you, why is it that particles in solids can't move, those in liquids can move, and so on, you refer to this. That's quite an important phrase here. Call them attraction forces. They hold the particles. When they're strong, then we're in a solid. When they're weak, we're in gases. And when they're non-existent, very, very, very weak, then we're talking about gases. Okay? Now, let me just recap on solid. That's solid ice, right? Remember what we said about particles in a solid? We said they're organized and they only vibrate. Now, look what I wrote here on the top. I said that solids are fixed shape. What does that mean? Meaning, if I take this cube, all right, that's a cube of copper, metal, and I walk around, take it from here to France, to US, I went up to the moon, you'd expect that cube to change its shape? Never, right? As long as it's solid, it's not going to change it. You may tell me, well, like, look, the ice is going to change its shape eventually. No, it would change its shape when it turns into, like, when it melts, right? But as long as it's solid, it's not going to change the shape. The dimensions are going to be the same. I mean, the size, the volume is going to be the same. I want you to think for a moment, how are these properties here going to be different when it comes to a liquid? In terms of shape, in terms of volume. Think about it. If this ice here turns into liquid, would the shape be fixed? Would the volume be fixed? So in liquids, this is how particles are in liquid. We said that the particles can slide upon one another, right? So in terms of shape, if I take a bottle of water like this and I pour it into a cup, what do you expect to happen to the shape? The shape is going to change. So liquids don't keep their shape. They don't have a fixed shape, right? What about the volume? Will the volume of water change as I pour it from one place to another? So shape is not fixed, right? The volume is fixed. Meaning, it doesn't make sense that I buy a small bottle of water, I put it in a bigger bottle, and then the volume changes. That doesn't make sense, right? So liquids have fixed volume, but not a fixed shape. Let me show you this once again. So that's a solid, okay? What the shape of this solid is going to be like, no matter what you do, it's not going to change its shape, right? Liquids, you pour it, it would take the shape of the container. Wherever you pour it, it would take the shape of the object or the container where you pour it. Now, take a moment, think about gases. How is the shape and volume of gases going to be like? If you take a gas, open that cap here, what's going to happen? The shape is changing, right? What about the volume? The volume is going to change, right? So gases don't have a fixed shape, they don't have a fixed volume, right? All right, so one last property I want to tell you about is this. We call this compressibility. How much you can squeeze a state of matter. So just take this example. If I have these three states here and I try to compress them, try to squeeze them, right? Which one is the one that is squeezable and which one is the one that's not going to be not squeezable? So let's try. As I compress a solid, they are not compressible, right? Why? Why is it that the solids don't get squashed, don't get squeezed? The reason is that a solid, the particles in a solid, remember how is it like? The particles in a solid, they're very closely packed. So there's no way you could compress. There's no spaces between the particles. Not even in liquids. Sometimes people think, well, I can squeeze the bottle of water. No, you can't squeeze a bottle of water. You're squeezing the gas in the bottle of water, right? Gases are squeezable. So again, someone asks you this, why is it that solids and liquids are non-compressible? You'll say there are no spaces between the particles. All right? So once again, you have this balloon here, right? Particles in the balloon, they're distant. You can squeeze the balloon, right? But on the other hand, if it was a liquid, if it was a solid, there's no way you could compress. The very last thing I'm going to talk about is this. We call this diffusion. What is diffusion? Diffusion is like the case if you have this fragrance here, right? You've decided to open that cap here, right? Suddenly, if it's a strong one, if it's a good one, you would be able to smell it, even without spraying, right? So, what is diffusion is all about? Diffusion is the fact that particles, especially I'm talking about particles of a gas and a liquid, they spread, right? So again, take this example. I have this solid. It would never diffuse, right? Try a liquid, pour like some ink into the liquid, it spreads, it diffuses, right? Try with a gas, it diffuses the most. Gases diffuses fastest than anything else. Think about it. Why is it that particles in a solid don't diffuse at all? In a gas they diffuse and in liquids they diffuse. Actually, in gases they diffuse way faster than anything else. Do you remember something we've mentioned today that explains this? Something explains why is it that gases and liquids diffuse and solids don't diffuse? Very good. It had to do with the forces of attraction. Remember, the force of attraction is solid, they're very strong. They're not gonna let the particles diffuse. In liquids, they are weaker, so they diffuse to some extent, right? But gases diffuse way faster than anything else, right? So take this example. That's bromine. Look what he's doing. He's taken another jar, put it here. once he put those two jars on top of one another, see what happens? The gas, the vapors, spread from the bottom to the top. I want you to take a moment and think, how's these jars gonna look like after like a couple of minutes? So if I just let these gases spread and diffuse, how's it gonna be like? After just a little while, you'll find that the gases are evenly distributed all over the two jars. That's what usually happens. You spray perfume in one corner of the room, you would smell it all over the room. Particles of the gas that will spread to take the entire container. Here I want to tell you something very important, something they try to play mind games on you in exam papers, which is this. What is that? Sugar, right? Sugar is a solid, right? Will solid sugar diffuse? You'll tell me never. It's a solid. Particles are strongly attracted. They're never gonna diffuse. In exam paper, especially multiple choice, they give you this scenario. You took solid sugar, you put it into tea, water. You taste the liquid, it tastes sweet. How did the solid here, how did it diffuse? We just said that solids don't diffuse. So how did this happen? The secret is that when you put the sugar in the water, it dissolves. When it dissolves, it's no longer a solid, right? So for a solid to diffuse, it must dissolve first, and then it would spread and diffuse. So this is something they just try to play with, right? So again, just keep in mind that solids don't diffuse as long as they are a solid, but when they dissolve, they do diffuse. Right? So let's just check our understanding. I'm going to show you a list here. Solid, liquid, gas. And I want you to try this in the chat box. Just put S if you think the properties for a solid. Put L, think it's the liquid. Put G if you think it's a gas, okay? So I'm going to show you the property, and you tell me what is the state of matter I am talking here about. Let's start with this. Does this apply for solids, liquids, or gas? Which one of these is the heaviest? Which state of matter is the densest, the heaviest, the one that has the greatest number of particles? Very good. That is, again, put S, L, or G, okay? So this time I said no diffusion. S, L, or G, what do you think? Which one does not diffuse? It is this one, right? Try again. Which one has fixed shape? Think about it. Which one of these three states is the one that has fixed shape? There's only one of them that doesn't change its shape, right? Which one is gonna be the one that diffuses at the highest speed? S, L, or G. Highest speed, diffuses the most, okay? Gas, right? Isn't it? We just said it. Which one of these has the strongest force of attraction? Thank you, Aya. That one is air, right? Which one? Don't rush. I did not say diffusion, I said slow diffusion. This one is, just check your understanding. Slow, it diffuses, but diffuses slowly. All right? We said solids don't diffuse, liquid and gas diffuse, but slow diffusion is for liquids, okay? Which one has fixed volume and fixed shape? Everything's fixed. Goes here, And which one has fixed volume but not a fixed shape? The volume is fixed, but the shape is not fixed. Goes here, right? Lastly, highly compressible, meaning you can squeeze it to the max. Which one you can squash? This one, right? Alright, yeah, so I was planning to do more of this. Just gonna stop here. And yeah.